Hi, thanks for being with us today for this feature on IUEC.org, where you'll find all the latest and greatest information on the elevator construction industry. I'm your host, Allison Harrell. We just had a chance to visit the 2014 IUEC International Meeting. Among the classes, discussions, and roundtables was the gem of the show, the big NEIEP show floor. NEIEP, or National Elevator Industry Educational Program, is how members of the IUEC get their training. The union, in conjunction with our contractor members, invests our own money into making sure that the next generation of mechanics gets the training they need to survive and thrive in our 21st century workplace. Topics run the range from CPR and safety to welding, switching, and everything in between. In this first part of a two-part series, we caught up with Lester White, Head of Development for NEIEP, to learn about how the program is doing.
It's a really exciting time. We've been going through all of our curriculum, looking at what we actually have, and looking at ways to refresh or renew the current stuff. We're also looking to add quite a few new training classes for the mechanics. So initially what we did was a reimbursement program where a guy could go out, he could take welding somewhere, and then we would reimburse him for his costs. We then started to create trailers that were mobile. The trailers would come to a local, the guys could go in, practice, and then get certified in 3 or 4G welding. Now what we're doing in addition to that is where there's locals that have enough room to host their own welding, we're going in and putting in a NEIEP welding facility. These are both standalone labs. So the door operator can be used as a lab by itself, and then the hoistway lab can be used as a lab by themselves, and then we can tie them together so that you can see how the controller controls the motion of the car and also controls the door. This was originally designed to run off of a PLC, and I think this has been in the classrooms for 5 or 6 years or so. We're actually progressing over to a newer technology, which is microprocessors. And they're in the process of building a microprocessor controller that will, in the end, control the larger elevator and the smaller. We'll also be able to do master-slave connections. We'll be able to do troubleshooting through Bluetooth, through a phone or a tablet. We'll be able to show them how to communicate from one of these microprocessors to multiple others. This is what the mechanics are going to see in the field. This is what elevators are running on now. This lab is designed to teach a student all the different ways to start a motor. The students will have to wire this up themselves based off the schematics. We'll cover all of the essential ways that they're going to see in the field for wiring. So we'll do across the line, forward and reverse, wide delta. We'll do time circuits. And one of the biggest things that they're starting to find, especially in hydros, are soft starters. So they'll learn how to wire up a soft starter, and they'll learn how to replace a wide delta with a soft starter. The nice thing about this is that normally the students will get pipe, they'll bend the pipe, and they'll show that they can bend a 90 or that they can bend a saddle bend. This actually challenges them to build and make bends according to a schematic, where one piece of pipe has to interact with another. They'll also be challenged to make their own pull sheets and then actually wire this up. This represents the controller, this represents the ductwork that they'll find in the hoistway, and this represents the hoistway itself. What we've done is we put together a lab that is kind of twofold. First, they can do chain and belt alignment, which is something that you're going to find on hydros. Then you move over to this by changing the orientation, and you can do direct coupling, which you're going to find on tractions. We go over the different type of couplers that they're going to encounter, the tolerances that they have to maintain with those couplers, and then we teach them how to actually trim the motors to work with those couplers. We give them shims, and then they actually do the work. So they get hands-on experience with this. This is a multi-platform base where we first teach them how to install rails, And we do standard rails, we do formed rails. Then we get into how to install a car frame and counterweight frames. They can do shiv alignment on this, and then they can also do cable jobs. These are the shackles that you're going to find in the field, and they actually would use these to run cables. For years, NEIEP has done DC motors and generators, but we haven't done any labs with AC. This is the first prototype for that lab. This is a specially made motor. It's low voltage, 115, 230 volt, 3-phase. It can be configured to be 4 different motors. So it can be a 3-lead Y, a 3-lead Delta, a 6-lead, or a 12-lead. And the ideal is you start them off on the simplest motor, which is a 3-lead Y, and you train them up until they can wire a 12-lead motor. And then no matter what motor comes on the job, our mechanics will know how to wire them. This was actually a request from the trustees. Safety is a very big issue in our industry, and job compliance. So we were asked to bring in CPR, first aid, and AED training. This will be the first of its kind for our industry. Within the next month or two, we'll have half of our membership trained to go back out and train the rest of the country. This is our new hydro lab, and it's designed to train guys on how to adjust hydraulic valves. These are the 2 hydraulic valves that you're going to find in about 90% of the hydraulic elevators in America. So we work with both of those companies to produce this training for our membership. It gives them the hands-on experience of not just telling them how to adjust it, but that they can actually feel and understand what each adjustment does in the adjustment. So this allows you to switch from one valve manufacturer to the other, so you can get experience operating and adjusting each one. This represents the car, and that represents a load in the car. These practical labs that we're coming up with give them that opportunity. They get to touch and feel things that they're going to use in the field before they ever get out there.
That's it for part 1 of this 2-part series on NEIEP. In part 2, we'll show you 3 new exciting ways that NEIEP is leading the construction education area, with a virtual elevator, a virtual escalator, and a QR code-enabled 3D model. If you liked this video, share it with a friend. Until next time, I'm Allison Harrell. Thanks.